Hey, what's up guys? Back again with another video. In this episode, I'm going to teach you about Java 17 sealed classes. Alright guys, I'm back. This is my first video using the face cam. I actually did this earlier, but I was recording the wrong screen, so I'm very salty about that. So I'm back. This is my first time showing my face, so I'm very nervous, but this is going to be cool. I think that it's more engaging and more intimate when you show your face and show yourself talking. That's how I see it, at least. And yeah, this is going to be something I'm trying now, so try not to roast me too much. Just one thing I'll say though is that my biggest enemy is my hair. I don't know what to do with it. I've always struggled with my hair, so it may just look crazy. So I'm gonna just this is my hair in this video, okay? Besides that, let's get started here. I hope you enjoy this. If you have any ideas for how I can improve the videos, let me know. I just put my face at the bottom right. It looks good so far, but I'm worried that it's gonna block the code. So if you have any ideas, let me know. And hopefully I'm going to save up for a stream deck so I can press buttons to change the scenes and all that. So we'll see where that leads, okay? So hopefully you enjoy this. Let's get started. So at the time of this recording, Java 17 just came out, which is, it doesn't have too many features, but it is the new long-term support version of Java. So that's good for adoption. So big companies can adopt Java 17 probably more quickly. And also, it doesn't really have that many features that everyday Java developers would use. The main thing that Java 17 added for Java developers is sealed classes, which I'm going to be teaching you about. So a sealed class is essentially a class that, well, let me start with this. So how can you prevent a class from being extended currently with your current Java knowledge? So at the moment, the way you would do that is by making the class final. So when you make a class final, this means that the class cannot be extended by any other class. So if you don't make a class final, then it can be extended by anything. So there's not really an in-between for, making classes extendable or not extendable, except maybe access modifiers to make the class not accessible within other packages and stuff like that. But other than that, there's not really a way to do that. So something that lets you do that are sealed classes, and it's a really cool feature. And it really, in terms of object-oriented design, it's really cool because you can now control the access of your hierarchy. So you have parents and subclasses or children under that, and you can control which ones are extendable and not extendable, and you can create a closed hierarchy if you want, so your code is not extendable by other people's code, for example, or something like that. And also you get some sort of safety. You don't have to defend your code against other implementations of your code. All right, so sealed classes, the first thing I want to show you is how to make a sealed class. Before we go into more detail explaining it and stuff like that. So we're going to make a new package called classes, because sealed classes actually, it's not just for classes, it's also for interfaces. So I'm going to demonstrate both. So we're going to make another package called interfaces. There we go. So in classes, we're going to have a new Java class called parents. This will be the top level class. Now, this by itself can be extended by anything, right? It's just a regular class, and it's public, so it can be extended by pretty much everything. There's no restrictions on what can extend it. But if you make it final, like I said, then nothing can extend it. So there's not really an in-between between making it completely unextendable and making it open. What you could do is just change the access modifiers of the class so it's not accessible within the outside packages and stuff like that. But, that's one thing you can do. But also with the sealed classes feature, you can actually specify the specific classes that can extend your classes, or even interfaces too, which we'll see in a second. So, so if you do public sealed class parent, this means that parent has to permit, using the permits keyword, certain subclasses that can extend the parent class. So if we go ahead and make a new class called child, then now public class child is required. Well, if we specify it, so permits child, now child is the only class that can extend parent, but also child is now required to extend parent. So it's a relationship where they're forcefully connected in a way. Okay, so public class child extends parent. So now this condition is satisfied, so that is no longer worried about that. But one thing that we have to worry about now is that every subclass of a sealed class has to choose one of these three options. You have to, 1, make it final, 2, make it sealed, and 3, make it non-sealed. You have to declare it specifically as non-sealed with a non-sealed keyword. So in this case, if we want parent, or if we want child to be extendable itself, then we can go ahead and make it non-sealed or sealed. If we want to limit what can extend it, then we use sealed. If we want to make it extendable by anything, then we use non-sealed. If we want it to be extendable by nothing, then we use final. Simple enough, I think, right? You'll get the hang of it once you see some more examples here. So in this case, we're going to make our child here as sealed as well. So in this case, we want child to be extendable by other classes. So we'll do permits, and we can make some new classes. We'll do other child and another child. Okay, there we go. So now the only classes that can extend child are other child and another child. And this also gives you access to parent, because parent, a child is a parent. So that's, you can make these technically parents as well, okay? So we're gonna make these classes now because they don't exist. So Alt-Enter is a shortcut you can do, and do enter, so create that class. So now you have an other child class, and then we have another child. So Alt-Enter, enter again, there we go. So now that we have these two classes here, they have to follow the same rule. They have to be final, sealed, or non-sealed. So just copy that here. So other child, let's say that we want this one to be final. We don't want it to be extendable anymore. So we have a parent, a child, other child, and another child. Other child, we're closing off to anything else. So we're closing the hierarchy in a way. And then other child, we're going to declare it as non-sealed, just so that we can see an example of a non-sealed class. So since we have declared it as non-sealed, it's essentially the same as a regular class that you're not declaring as anything, sealed or final. So in this case, you have this other child which is closed off, but then you have another child which is completely open to anything else that wants to extend it. And this sort of makes sense, right? Requiring that subclasses of a sealed class are final, sealed, or non-sealed makes sense, because the whole idea of sealing a class is cutting it off from the rest of the world. You want to explicitly declare the things that can extend it, right? So making it open, if let's say that we have parent, right? And making child completely open to the world to be extended, let's say we don't make it sealed, this would go against the whole idea of sealing classes, because then, since child is a parent, you're technically allowing anything to extend parent, even though it's permitting a child. So it makes the whole thing pointless in a way, right? But instead, if you want to, so if you close it off by sealing it or finaling it, then it's, making it so that you're keeping the contract of essentially making something sealed and not openly extendable. But then on the other side, you have non-sealed, so you're still able to make something open to the rest of the world. And it kind of makes sense if you think about it, right? You as a developer should be able to choose whether something is open or not. It's your design at the end of the day. Even though the whole idea of sealing classes is to make it not openly extendable, if you say something is non-sealed, then you're telling the IDE, and you're also telling Java that you've chosen as the developer for this to be open, and you're taking that risk or whatever, right? The design is really up to you, okay? So hopefully that makes sense. And I could be wrong about the reasons for them having to make this keyword here, or them adding this keyword to the language, but I assume that's the reason they did that. It makes kind of sense. It makes sense in my head when I think about it that way, okay? So now we have these 4 classes here: parent, child, another child, and other child. What I'm going to do now is, make a quick diagram so you can see the hierarchy of all these classes here, so that you actually understand what's going on, because it may be a little confusing. These names are pretty abstract, all right? So just give me 1 second. Okay, so I've got a little diagram here of our class hierarchy. If you're familiar with UML diagrams, this is not actually following the UML format. It's just a random flowchart that I made, so don't roast me about that. Okay, so I got a tablet down here so I can actually draw on the screen, so just watch the screen, or just stare at my pretty face. So we've got a parent here. This is a sealed class, as you know, so sealed. And we know that the only thing permitted by that parent to be extendable is child, because according to the rules of sealed classes, anything that you permit has to be the thing that extends it. So they're required, the child is required to extend the parent. So since child is the only thing listed here, we can assume that child is the only thing being permitted by parent to be extended. Okay, hopefully that makes sense. And then under that we have other child and another child, but child itself is sealed as well. So other child and another child are the only thing permitted by child. So other child, as you know, is final. This means that if we have another class down here, Bob cannot extend it. That's invalid. You can't do that. But we have another child on the other side called, it's non-sealed. It's declared as non-sealed. There we go. And so if we have a bunch of classes that want to extend that, that's perfectly valid because it's non-sealed. Okay? So you kind of have like a hole here in your whole sealed hierarchy here. Everything else is sealed or final, but this one's like the whole, so it like opens up the hierarchy to the rest of the world, okay? Hopefully that makes sense. And again, that design is up to you. You can do whatever you want, whatever you see is best, all right? So we're going to do interfaces now. We're going to go to our interfaces package and do new Java class, make it an interface, and that's going to be called shape. An interface, as you know, hopefully can be implemented or extended. It can be implemented by classes, but it can also be extended by other interfaces. So in this case, when we make this sealed, we're not only making it not able to be extended by anything that's not permitted, but we're also making it not being able to be implemented by anything that's not permitted. So if we do permits here, anything that's listed here, whether class or interface, it can extend or implement that, okay? So we're going to have two classes, or actually we're going to have one class and one interface to demonstrate both ideas of extension and implementation. So permits will have a triangle interface and then a circle class. So we're going to make those two things. So triangle, new Java class, triangle interface. And this is going to extend shape because interfaces extend other interfaces. All right, and believe that. And then we'll go back here. So circle now, so new Java class circle. So public class circle, we're going to do implements shape. So that makes sense. And now circle has been permitted. Now these classes here in this class and this interface now have to be sealed, non-sealed, or final. But as you know, an interface cannot be final. So if we try final, that's gonna be a bad thing. You can't do that. That's a no-no. So I guess the suggestion here should be changed because if we do this, it says sealed, non-sealed, or final, but you can't use final on a class or interface rather. So there you go. So we're just going to make it non-sealed, so it's able to be implemented or extended itself. And then circle, we're going to do it as sealed. It can be, this one is just a regular class, so it can be final, sealed, or non-sealed. But this one we're going to make sealed. So actually, we'll do final because we don't want it to be extendable by anything else. So there you go. That's how you can use the sealed classes feature, or technically sealed classes and interfaces feature of Java 17 with interfaces as well. So we're sealing the interface, we're permitting the classes and interfaces that can extend and implement that, and then we're going to those classes and interfaces and implementing or extending them, and also choosing whether to make it final, sealed, or non-sealed, okay? So same concept, I just wanted to explicitly show you how to do that with interfaces because it's good to have examples on that. Some further information on sealed classes. When you make a class sealed, this means that the children of that sealed class that are permitted to extend that parent class, they have to be in the same package of that sealed class. But if it's a modular application using Java modules, then it has to be in the same module. In this case, it's not modular, it's just a regular application with packages. So it has to be in the same package. So just to prove that, if we were to have parent here and we move child outside of the classes package, then now we have a problem. So if we go to parent now, it says permits child but has a thing. It says class is not allowed to extend sealed class from another package. And again, if this was a modular application with Java modules, then you can keep it in different packages, but it has to be in the same module, okay? All right, so anyway, that's that. And then another thing is that, so from the JEP page, the JEP stands for Java I have no idea. But JEP is essentially like an organization, I guess, of Java features. You can have, if you look on their page, there's a bunch of Java features, and some of them are implemented into the Java language. Some of them aren't. Some of them probably will never be implemented, but it's a bunch of features and ideas and stuff like that that the Java community can choose to, put into the language. And sealed classes itself is a part of Java 17 as an official release, but it was actually part of Java 16, I believe 15 as well, as a preview feature. So they can choose to put features into the Java language as preview, and then you can test them out, if you add the preview flag or whatever it's called, to use them in your programs. But now that the JEP 409, the name of the feature, JEP 409, is added into Java 17, you can use it without any issue. It's actually part of the language, okay? So if you're more curious about this, then just search JEP 409 sealed classes on the interwebs, and then you'll see the page, and you can read all the documentation and all that stuff, because that's pretty much the source of the feature, so it'll have the best documentation, probably. And then you can also view the other JEPs there if you're curious about that, so other features that might be added to the Java language, okay? So let me just read real quick 3 points from that page. So the first point, sealed classes allows the author of a class or interface to control which code is responsible for implementing it, which makes sense, right? We're explicitly telling our program here that parent can only be extended by a child, another child, or other child. It cannot be extended by anything else. So you get that sort of customization, that midpoint between final and non-final. The second point, provide a more declarative way than access modifiers to restrict the use of superclass. And then finally, support future directions and pattern matching by providing a foundation for the exhaustive analysis of patterns. So in the future, we may have JEPs or features for like switch statements that are intelligent that use pattern matching for sealed classes and stuff like that. This may be a thing that we see in the future, hopefully. And if you're not familiar with pattern matching and stuff like that, then check out my Java 16 instance of pattern matching video. It gives a explanation of that feature. Okay. Anyway, so last thing I'm going to tell you about, finally, my voice is about to die, is additions to the Reflections API for sealed classes. So Reflection API. If you're not familiar with the Reflection API for Java, then it doesn't really matter. This doesn't really concern you too much. But it's pretty simple. So if we have a parent object, so parent is equal to new child. So it's a parent variable reference, but the actual object is a child, and a child is a parent, so that's valid. And so we can say if parent.getClass, so get the class reference, is sealed, then it'll return true or false. And then we could say something like sout permitted subclasses arrays dot toString, and we can do parent dot get class dot get permitted subclasses, and now it should print out an array as a string of all the permitted subclasses of this parent variable here. And otherwise, if it's not a sealed class, if this condition up here was false, then we can just say this ain't a sealed class, homie. Okay, so let's run this program to see what happens and what gets printed out. Okay, so we get down here, permitted subclasses, other child, and another child. So that's interesting, right? This is a parent variable, so it's a reference variable to a parent, but the object itself is a child object, right? So you may think that the thing that should be printed out is just child here, right? Because that's the only thing permitted by parent. But since the object itself is a child, the thing that actually gets printed out is the permitted classes of child. So if we go to child, we see other child and another child. So all that means is that you have to be careful of what you're checking. So even though, by first glance you may expect it to just be a parent, it is a child. The object is a child. So something you may want to do, maybe there's a better way to do this. You can say if parent instance of child C, then you do that. You can just change these to C to be more clear, although it's the same thing. Okay. Otherwise, else, then you can maybe assume it's a parent, like an actual parent, although it can be another child and other child, but you can add those conditions as you wish. So this is a parent, probably, or not. Okay, so just be more clear. So yeah, just be careful about that. And so those are the two new methods added to the Reflection API to work with sealed classes. You have isSealed to tell if a class is sealed or not, and then you have get permitted subclasses, which is an array of class references for this permitted subclasses, okay? All right, so that's it. That's pretty much it for this video. I showed you how to do sealed classes now, so that's how you can make a sealed class. Permit was able to extend it. Then you declare those subclasses as final, sealed, or non-sealed. And then, yeah, it works with interfaces too. So pretty simple feature overall, and it should make your object-oriented hierarchies more interesting and your designs more interesting when we start using them, okay? So hopefully you like this explanation. If there's anything you want to add to this video, if there's something I missed or didn't explain well, then go into the comment section below and just leave some more info if you want to help out your fellow coders and help me out too. That's pretty much all I got. One thing I will tell you is that in the description below, you'll see a link to the code for this episode. So you'll see something like this. So you'll see the project with all the comments and stuff like that. So you can read it and, you know, refer to it if you want to. You can bookmark this page if you need a reference for SIL classes. And yeah, it's helpful if you don't want to have to rewatch the whole video to know what everything's about and how to use SIL classes, okay? So link in the description below, make sure to check that out. But also in the description below is a link to our Discord server, so you can join that community, get involved with, you know, fellow coders, people who also like coding, but also you can get help on your programming projects or stuff that you're stuck on. Maybe you want some advice on how to become a programmer, anything. It's a really great community for programmers and stuff like that. So make sure to join that, okay? One final thing is if you want to support this channel, then click the join button below this video, and you can join this channel as a member for as low as 99 cents a month, $5 or $10. So it comes with some cool perks like early access to all of my new videos, including this one here. You can see all of my new videos ahead of everyone else. Sometimes it's even for months, just like my spring videos. Also, you get a cool rank on my Discord server, so you can show everyone how cool and swaggy you are, so you can get the ladies and stuff like that, you know, with the cool rank. And finally, you get to, oh my gosh. Oh my god, my muscles are huge. And finally, you get to see yourself on the screen like you see right now. Awesome, right? And that's it. So if you like this video, leave a like. If you want to see more, subscribe, and peace.